Good morning, teacher. My name is Andrea Vivero. I will talk about mechanisms of spinal cord regeneration. So, definition. Spinal cord injury is defined as traumatic damage to the spinal cord or nerves at the end of the spinal canal. This affects the conduction of sensory and motor signals across the site of the lesion. They are two types, incomplete and complete. Incomplete lesion, not all the nerves are severed or the nerves are only slightly damaged. Recovery is possible but never to the pre-injury level. Complete lesion, the nerves are severed and there is no motor or sensory function preserved at this point. About the anatomy, the spinal cord is the major conduit through which motor and sensory information travel between brain and body. The spinal cord contains spinal tract, white matter, surround central areas, gray matter, where most spinal neural cell bodies are located.
The spinal cord is the body's information superhighway, constantly buzzing with electrochemical signals between the brain and the rest of the body. This precious bundle of nerve fibers runs through a cavity within each vertebra. This protects the cord along its length. But even this bony armor can't protect the spinal cord from the worst injuries. With enough force, this delicate cord can get damaged, cutting off all communication to and from the body below the injury site, leaving a patient paralyzed. This devastating injury happens to an estimated 500,000 people each year across the globe. To make things worse, the damage is irreversible. Neurons of the central nervous system don't seem to be able to regrow their axons, the long spindly projections that link them to other neurons.
Application in physical therapy. The rehabilitation of patients who had a spinal cord injury depends on which level of skin the injury occurred. Also, the therapy depends on whether it was a complete or incomplete spinal cord injury. In case of an incomplete spinal cord injury, 25% do not become independent ambulators. The therapy differs according to where the lesion happens, cervical, thoracic, or lumbar. The rehabilitation of SCI is a multidisciplinary approach. Possible upper incomplete SCI therapy. Patient needs therapy for movement and strength recovery of the upper body. Probable um, respiratory training. Respiratory muscle training consists of inspiratory, expiratory, or both improvement in muscle strength and endurance. Therapy using BOA principles combined with functional electrical stimulation. Possible lower. The main limitation with lower incomplete are that they have reduced coordination, leg paralysis, and impaired balance. Pros and cons. They are easily obtainable, autologous transplantation is possible. They have the ability to migrate to areas of damage and inflammation. Cons. Failures in spinal recovery, cell collect may be of poor quality, increased relapses, and bleeding.
Strategy is to change the environment swelling round the damaged nerves to make it more growth-friendly by dialing down chemicals that inhibit the ability of nerves to regenerate. One set of molecules that are suspected of blocking regeneration are called chondroitin sulfate proteoglycans, CSPGs. Scientists have shown that by using an enzyme called chondroitinase, they can change the structure of the CSPG molecules so that they no longer block the growth of axons. The second strategy is to introduce factors that work directly on the cellular machinery of the damaged neurons to boost their capacity to heal themselves. For example, researchers are trying to make the neurons more receptive to pro-growth signals from their neighbors. Receptor molecules called integrins seem to disappear as neurons mature, so researchers are looking for ways to smuggle integrins back into damaged neurons. Researchers are also experimenting with adding in the growth factors themselves. For example, proteins IGF-1 and osteopontin have again been shown to spark axon regrowth. A third strategy has the potential to combine many aspects of the first two. A study in rats has shown that mesenchymal stem cells, or MSCs, naturally home in on the site of injury and protect against secondary damage caused by the immune system. They also appear to promote axon regeneration, repair damage to the axon's insulating layer of myelin, and may be able to directly transform into new neurons. A small trial using MSCs in humans was completed last year, and the results are due to be reported soon. It's likely that a successful therapy will involve a combination of these ideas, hopefully giving patients with spinal cord injuries a brighter future.
Issue split in Ecuador. The incidence rate in Ecuador of people diagnosed with traumatic spinal cord injury was 28.1 case per 1 million inhabitants. 54 percent of traumatic spinal cord injuries affect young people between 16 and 30 years old. 50% due to traffic accidents, 20 and 30% due to accidents, 4 and 8% due to work accidents, between 4 to 11% due to physical activity and leisure activity, 1% due to race. In addition, paraplegic women are more frequent than quadriplegic women.
There were a number of interesting findings. A survey undertaken at the same time identified 10% of spinal cord injury patients had not actually been referred and treated under a specialist spinal cord injury centre. And of 744 discharged patients during a 12-month period, 72% were male, and 71% of the spinal cord injuries were due to trauma. The breakdown by level is shown on the right at the bottom of the screen. Now, in the UK, 42% of traumatic spinal cord injuries are the result of falls, 37% from road traffic collisions, and 11.6% from sports. The breakdown here shows the fall from a height, fall from stairs, fall from standing height, or jumping injuries, and the non-specified. The breakdown from road traffic collisions shows the fall or more wheeled vehicles, motorcycles, cyclists, and then the smaller number of pedestrians, and then the unspecified road traffic collisions. And for the sports breakdown, diving, rugby, and horse riding activities are those most associated with the spinal cord injury.
In conclusion, spinal cord injuries are a serious respiratory health issue resulting in a large amount of dysfunction and as such have a big socioeconomic impact. Therapy is multidisciplinary and the focus should be on regaining function relevant to the patient, as tissue recovery is often impossible. Stem cells hold promise for spinal cord repair, but their true potential has not yet clearly been shown. At this time, stem cell-based therapies are at an early stage and the associated risks are still unclear. When a patient has a disabling or life-threatening disease, a case might be made for surmounting the existing ethical and social barriers to enable treatment.
So far, Asterias' animal studies and their ongoing human clinical trial have shown promising results. Safe implantation of the cells and, as a result, increased motor function. But it is important to remember these results are early, and this stem cell-based therapy must be tested further. With the successes we will celebrate, there will inevitably also be setbacks and obstacles along the way. However, even setbacks will provide learning opportunities for further scientific and medical exploration that will bring us closer to curing or mitigating conditions such as severe spinal cord injury.
Thanks.